In this class we're going to learn how to predict the equivalence point in a titration. And I've asked the question, a 25.01 ml aliquot of 0.1007 molar hydrochloric acid is titrated with 0.1233 molar sodium hydroxide. Predict the equivalence point. Just a new word you might not recognize. Aliquot means simply a portion. So I would pipette a portion of some liquid, or I would feed it in with my burette. If it was 25.01, it would likely have been delivered with a burette. Normally when you do it with a pipette, it'll be something like 25 ml, 10 ml, or some even number. At any rate, keep in mind that when you have a concentration and you multiply it by a volume of that liquid, it'll give you the number of moles. So N is equal to the number of moles, acid or base. M is the concentration in moles per liter, and then the volume is in liters. This is the reaction. It's good to portray the chemistry that's taking place when you do a titration. So hydrochloric acid is being titrated with sodium hydroxide, and really the net reaction, what's really happening is that the H plus from the acid is combining with the OH minus of the base to form water. And then you also get a salt. But the net ionic equation, the spectators cancel, so you don't see the sodium chloride. You don't include it in the net ionic. So we use the same equation to predict the equivalence point to the stoichiometry as we do for dilution. M1V1 equals M2V2. Here's the concentration of the acid. Here's the volume of acid. Notice I left it as mLs. It actually doesn't matter what unit you use as long as you're consistent left and right. So if you use mLs for the volume, then use mLs on the right. Because we're not actually trying to find out the number of moles. All we're trying to find out here is the volume of base that's going to be necessary. If you were trying to find out how many moles was being used, then you would have to use liters, because to cancel moles per liter, you have to put liters here to get moles. But we're not looking for that, we're just looking for mL. So we've got 3 of the 4 variables, so we can solve for the 4th one. And V2 turns out to be 20.42 mLs, 425, which round up to 20.43 mLs of base solution. You'll notice there are only 4 sig figs here, 4 sig figs here, 4 there. So our answer can only contain 4 significant figures. In the second question, which comes from our text, 10th edition, we're asked if you titrated 0.115 molar perchloric acid with a solution of 0.0875 molar sodium hydroxide, and it takes 50 mLs to achieve the titration, what volume of perchloric acid did you have? Maybe I should refer you to the question. You're titrating this sample, a 50 ml sample of 0.0875 molar sodium hydroxide, and your titrant is 0.115 molar perchloric acid. How many mLs of perchloric acid are going to be necessary? You should predict it, because when you predict the amount that you're going to need, when you carry out your actual titration, it's good to know what the neighborhood of the amount that you're going to have to add is, so you know to slow down around that at that point, as you will see when you do a titration yourselves. So we have 3 out of the 4 variables. We'll solve for V1. Turns out we need 38.043 mLs of perchloric acid. Because there are only 3 significant figures in this problem, then we can only report our answer to 3 significant figures. So the answer turns out to be 38.0 mLs of perchloric acid is needed. And here I show the 3 different equations that I taught you yesterday: the molecular equation, the ionic equation, and the net ionic equation for the reaction of perchloric acid with sodium hydroxide. You see here the molecules that are involved. This is your product. This solution here, this remains in solution. See, it remains aqueous. So at first glance, it might look like there's no reaction taking place, because I remind you, I told you yesterday that when you see a solid precipitate, then you know there's been a reaction. But in this case, you don't get a solid precipitate. What you get is water. And when you do the ionic equation, you show everything dissociated. So the HClO4 breaks into protons and perchlorate anions. The sodium hydroxide breaks down into sodium and hydroxide anions. And on the other side, you still see the Na and the ClO4 dissociated. but the proton and the hydroxide combine to form water. So when you cancel out all the spectator ions, you get what's called the net ionic equation, and what you see is H plus combined with OH minus to give you water. So you should be able to show the reaction in those three different ways. In any acid-base reaction, this ends up being the net ionic equation. No matter what strong acid you mix with what strong base, you know there's 7 strong acids and there's 7 strong bases. You take any two and you mix them, this will be the net ionic equation that you're getting. You're getting H plus combined with OH minus to form water. In the next question, and it's part of your homework, I would like you to try to solve 479 and 480.